Hello, my presentation is about running oVirt in a home lab setup and also running it on a laptop. So my name's Paul Staniforth and I work at Leeds University in the UK as a network systems analyst, working in the BEC school, which is the Built Environment Engineering and Computing School. So why would you want to run a home lab? So some of the reasons are a lot of people are working from home these days. It's a good way of checking out new ideas, especially if you've got policy restrictions at your workplace on security requirements and new projects need to be checked off before they can be deployed on site. And also, it might reduce the network requirements for remote access. So one of the advantages of this is using a laptop. So we can produce an all-in-one solution. It's also highly mobile and standalone. It's got the other advantage really of a laptop's got a built-in UPS system, and it's quite useful if you need to demonstrate solutions to other people. It's transportable, easy to pack away and take out. So some of the advantages of a home lab are you can run it on bare metal, so running it directly on hardware if you happen to have accumulated systems over time or you have extra machines underutilized. And the other way of doing it is using a nested virtualization system. Or we could use a hybrid model where part of it is nested and we can also have other parts running on hardware nodes. So the main hardware requirements are memory, especially if we're using virtualization because it tends to consume a lot of memory. CPU usage tends to be less unless you're running some high-level software. But in this case, we're just testing out systems and working out methods of deployment. Other things that tends to get consumed a lot is storage. It can quite easily consume a lot of storage, even if you're using thin deployment methods. And networking, it's very advantageous to have a decent networking setup. One of the advantages of running systems now is we can automate a lot of stuff and provision stuff. So a lot of the work and repetitive tasks can be automated. It's probably better if we choose a solution that works for bare metal as well as virtual systems. So in the case of setting up and managing hosts, and the virtual machines themselves, we can use similar software and packages that can manage both. Some of these include Ansible, Puppet, using scripting or Python shell scripts. Some provisioning systems such as Foreman and Catello work quite well with oVirt and can manage the hosts and nodes as well as the virtual machines themselves. Another thing is Red Hat Satellite, which is based on Foreman and Catello. And Manage IQ is another solution. There's probably quite a few more, but that should be enough to be getting started with. So there's a number of virtual solutions. One of them is libvirt with KVM. So we want a solution really that can utilize nested virtualization, so we can run our virtual desktop environment within a virtual system itself. And some of the other ones would be things like VMware, Azure, and VirtualBox. There's also some cloud providers that do nested virtualization. So some of the issues to look out for when we're using a networking is to try and isolate it from the rest of the network at home, preferably with a separate segment, so we don't interfere with the rest of the household network. We don't want to do changes that can interfere with people's Netflix viewing. It's quite advantageous to have a VLAN switch if possible, but you can deploy oVirt on a laptop using nested virtualization without any external connectivity, just using that. So the solution I'm talking about here is based on KVM and libvirt. And the reason to choose this are it's free and open source. It uses the same tech as oVirt, and it's quite easy to automate. It's also familiar to Linux users, and it can use different tools to access and manage it, such as Virt Manager for a graphical interface, the machines plugin for the cockpit web-based management system, or Visha as a command line tool. And that also lets you create your own scripts. So to run a nested environment, we need to turn on the features to create a nested virtualization system. So we need to turn on hardware virtualization in the BIOS. We also need nested virtualization to be turned on in the kernel. And also, in our case, because we're going to be deploying oVirt nodes or hosts, we need to enable virtualization on the nodes. So to test whether we've got nested virtualization enabled, we can cat the nested parameters feature in the sys module, and that should come back. If it's disabled, it should come back with an N or 0. So then we need to edit the KVM configuration file in the modules system. So it should have commented out the options for nested. So depending on whether you got Intel based or AMD based CPU, you'd uncomment the relevant line in the configuration file. Then unload the appropriate module and then reload it. And hopefully when you then cat the file, it'll show yes, a Y or 1 to show that it's been enabled. So one of the ways to enable nested virtualization to work within the virtual machines themselves is to use a virt command to edit the virtual machine and set the CPU mode equal to host model. You can also do this in the GUI. So some of the components required are networking, and it's probably better to use, if you've got a standalone system, use bridge networking if you need to access the network outside of the virtual infrastructure on your host. You can also use NAT, which is set up by default on KVM and libvirt. And that'll work, especially if you just want it all configured within a single laptop. One of the things you're going to need for this setup is DNS. So if you've got a DNS system running, maybe on some hardware, or even a Raspberry Pi might be providing your own DNS. But within libvirt, the networks are configured with a DNS masquerading daemon that provides DNS. But it might be better to run it on the host machine itself, because any changes you make need to be communicated to the libvirt DNS masquerader by stopping and restarting the virtual networks. That might be a bit tricky if you've got VMs running. One of the things it does by default, though, is it will read your host file on the machine it's running on for any, and supply those as DNS replies. And it'll also forward on the DNS to whatever your DNS server is configured to within the host machine. So we get a lot of options with storage. So libvirt itself has a concept of pools. There's many options for these. There can be just a standard directory on the system, or it can be a ZFS file system, or a logical volume. And within these pools, we can then create storage devices that libvirt classifies as volumes. And these are the things like disk images and stuff like that that will be passed to the virtual machines. So it can also be ISO files. You might also have a NAS or SAN system set up that you can utilize for this as well. So when we're setting up storage for domains in oVirt, we could set them up on the host server, the one that's hosting the VMs and libvirt. So you maybe set up an iSCSI connection from the host itself, or network file system storage. But one of the things to note is libvirt by default has its own firewall zone. So if you're setting up a network file store and enabling the firewall, remember to do it in the one that's connecting to libvirt, that it does over a separate network, usually addressed as 192.168.122 on CentOS versions of Linux and Fedora versions of Linux. One of the things I found, but also with the default network setup, it's supposed to have a domain name set to the network name, and it has default set by default, but it doesn't have it correctly configured. So you need to edit that if you're going to utilize it. If we're going to use resources externally, it's probably better to use bridge networking, and we do that by setting up a bridge on the host system itself, and then it'll be visible within libvirt and KVM. We could also set up the storage domain, so we could set up virtual nodes to provide NFS or iSCSI, or also we can create cluster nodes and create a cluster network. So after talking about this briefly, I'm going to do a short demo. So here's a quick demo of a system configured hit that I have here. As you can see, it's a standard oVirt system with the admin VM portal. We've got two virtual hosts that are running the oVirt node system, and they've got a nested virtualization. So within that, there's another virtual machine, in this case running. Just got about a dozen of them installed on this at the moment, and we'll just check that everything's working out. Yeah, we can connect to the Kali Linux VM. So we've got two hosts running there, oVirt1.home and oVirt2.home. We've got some NFS storage being exported from the host machine itself to the virtual data center. And you can see we've got the VM portal all configured as expected. And if we look at Virt Manager, you can see we've actually got 4 virtual machines running. We've got the 2 oVirt nodes, oVirt1 and 2.home. They've got the standard oVirt node software installed, and there's 2 NICs, 2 virtual NICs attached to it. Actual ISO that they were installed from, and a couple of virtual disks. So the other way of enabling the virtualization to work is to configure it in the GUI and do the copied host CPU configuration. So we can see the connection to libvirt here. And we haven't got any virtual networks created. They've been deleted on this server, and we're connecting to a bridge device created on the host machine itself. But the storage pools are on here, so we've got downloads basically for downloaded ISOs, and another pool that we're creating the volumes in. This is just a standard directory, but we can create them with different types of things like ZFS, SCSI, iSCSI, LVM, a few other kind of storage pools. We just create a network here, so we can see it when we look at it from the shell. The other machine running is just a standard CentOS that we're running the oVirt software on, and this doesn't need to have nested virtualization running within it, because it's just running the management system. So we can connect to the system using a shell, and we can list the machines running, or all the machines, including the ones that are shut off. And we can see that if I do a net list, there's just that one network that I created before. And we can dump. And we can dump the XML configuration of that network, and we could do a bit of alteration and configure a new one based on that, or create our own using any other automation method. And we can also dump the XML from the virtual machines themselves. And we can load them up and create new ones, shut them down, restart them, pause them, and all, most of the other stuff. And we can also do the same thing with storage and networking. So we've got a libvirt firewall zone, and because this is actually doing the DNS, it's been activated on that. So that's a brief demo. So thanks for watching my presentation. I hope the rest of the day went well. Thank you again.